Hello, these are the exercises for section 6.5, inference for linear regression. So here we have an example that is on gas mileage, and you can see here in the X column, this column here, it's for the weight, and that's the X values. These are the explanatory values. Then we have the miles per gallon, which is our Y, which is our response variable. And you can zoom in closer on your document, but here, I'll do it real quick. You can see that, we have these axes, and you can go through and see it. And we can see it a little better as we go through and do the problem. Let's go to the right size. Okay, so we first want to ask yourself, are the conditions met for regression analysis? So the conditions are that we have linearity. Okay, so when you look at your scatter plot, does there look to be a linear trend? And there does, so that is satisfied. Then we want to make sure that we have independent observations. And we highly encourage you not to do time series if this is not a time series. And like this data value right here, up here at the top, is going to be not influence other data values. So we have independent observations. Then we look at this histogram of the residuals, and we want to see if we have an approximately normal distribution. So there doesn't seem to be any big outliers or really strongly influential points. Given this, we have sort of a bell-shaped curve. It's approximately normal, so we have that satisfied. And then last, we have constant variability. Okay, this means that when you look at your residual plot, that there's no obvious trend for this residual plot. Things are far from the line, close to the line, and there's no trend as you continue on with the X values. So that is satisfied. Okay. So now that we have it satisfied, we can go through and do our analysis. So we want to find the regression line. So we go, I'm going to highlight, oops, maybe you can go through and highlight this table and copy it and put it in my spreadsheet on GeoGebra. Okay. So I come here and I highlight them, and I come to two variable regression. Let's get the window so we can see everything. And you can see more closely, you can see the data. And this is just the scatter plot that we had on your lecture notes. We can at the bottom, let's see if I can see it. You can go through and say, I want a linear regression model if there's no line there, and it will make that. And you can see down here that we have our regression equation. Okay. So our regression equation is going to be y hat, so negative 0.0086 x plus 56.45. Okay. So now we have to go through and interpret our slope and our intercept if it's appropriate. So your slope, we all think of the slope as rise over run. It's going to be this coefficient in front of the x variable. So we have negative 0.0086. we think of this as rise over run, so we go through and make it into a fraction over 1. And then I personally go through and I say the rise, it's going to be going up and down. So the rise variable, variable units, is miles per gallon. So I go through and I put miles per gallon. And then I go through and my run is left and right. So that's my X. And so I go through and I put my units. In this case, my unit is pounds. Okay. So with that, we have kind of a standard setup for the interpretation of the slope. And I'm going to have the standard setup, and then I'm going to fill in the blanks as appropriate. So we have as we decrease or increase, depending. I'll talk about which one it is in a minute. Your run, like your rise over your run, we should expect your rise we should expect an increase or a decrease in your rise. On average. Okay, so we go through and you can kind of see we have a negative here in the top, and we're going to have a positive down here in the bottom. So since we're going to be doing our run, we want to look at this in the run. Since we are positive, we are going to be increasing. And we're going to increase 1 pound in weight, because that's what my X variable stands for. We should expect to, again, now we're going to look at the rise, because that's, we're looking here, and the rise is negative. So we're going to be decreasing. So as we increase 1 pound in weight, we should expect to decrease 0.0086 miles per gallon on average. Now when we want to go through and interpret the intercept, okay, this is going to be the y value when x equals to 0. So this is only going to be appropriate if these two conditions are met. One, that x equals 0 is reasonable. Okay. Once that is reasonable, it also has to satisfy that x equals 0 is within the scope of the model. Okay, and these both have to be satisfied to be reasonable to even try to interpret this y-intercept. So x equaling 0 means what? So again, remember, your x is your weight up here. Okay, so does it make sense to have your weight being 0 pounds? Since that is not reasonable, then it is not appropriate to interpret our y-intercept. Okay, so what is the correlation coefficient, and what does this indicate about the relationship? So let's go back to our GeoGebra, and we can click on the statistics information. And we have our R here, that's our correlation coefficient, so it's a negative 0.9892. Okay. So what this means is that this negative is that we have a negative relationship, and because it's close to -1, it's a strong relationship. So you have a negative, strong, linear relationship. Okay. Now I have to go through and see if there is significant linear relationship between this with this data. So we come back to GeoGebra, and you have to go through and in your canvas, come and work here, and I can copy and paste your data. I want to make sure I get it all. We have 7 data points. Okay, 7 data lines. Okay, so you can also see your R here. You can also go through and calculate your slope and intercept here. But what we care about here for significance is our test statistic and our p-value. Okay, so our test statistic is the t-value, which was a negative 15.08. And my p-value for this was 0.0001, 2, 3, 4, 2. Okay, so you want to compare this p-value to your alpha, and my p-value is less than my alpha, so we have a statistically significant relationship. Okay. So now we're going to go through and use our regression line to use it to find a prediction for the fuel consumption for the fuel consumption for a 3,000 pound car. So we're going to go through and we're just going to plug in y equals, we're going to plug in 3,000 for our weight because our x is our weight, and add 56.45. When you go through and you get that, you get 30.65 miles per gallon. I wanted to note to let you guys know that if you do go through and look at your GeoGebra down here at the bottom, it does say symbolic evaluation. You could plug in 3,000 here, and it gives you a y value. It's going to be a little bit different than our y value because we've rounded. So if you go through and you like set your decimal approximation to like 10 decimal points, then you'll get the same value as this on your calculator when you calculate it by hand. All right. So a particular 3,000 pound car gets 34 miles per gallon. What is the residual? So the residual is going to be your actual value minus your predicted value. The actual value here was 34. Predicted was 30.65. I'm using my approximated value here. And this becomes a 3.35. So that's how off our prediction was in miles per gallon from our actual miles per gallon. Okay, so our residual here is positive, and that means that my observed was greater than my predicted. So my observed was 34 miles an hour, and my predicted was 31 about miles per gallon, and therefore that's why it is. So the observed value is greater than average, above average. Okay. If your residual had been negative, that would have meant that your observed value was less than your predicted value. You could use observed here instead of actual. That would be fine too. It's probably more appropriate. Okay, observed minus predicted. So your observed value, if your residual is negative, is going to be below average. So let's go through and do the same thing and find the fuel consumption for our smart car that weighs 1,600 pounds. So my predicted value would be negative 0.0086 times 1,600 plus 56.45. Again, I'm doing my rounded numbers. And y'all get here 42.69 miles per gallon. So again, had we done the residual, we would have gotten another positive residual. I encourage you to try to figure that out. And that would mean that our observed value of, oh, sorry, we don't have the actual scenario here. I'm sorry about that. We don't have the observed value, so we can't figure out the residual. You can only figure out the residual if you have the observed value for a 1,600 pound car. Okay. All right. Now let's go through and do this last bit. Compute your R squared. So on both of your GeoGebra outputs, you find an R squared. So here's an R squared right there. If we went through and did it where we found whether we were significant or not, you can find your R squared here also. Okay. So you can see the R squared is 0.9785. Okay. And this means, to interpret it, that about 98.75% of the variation in miles per gallon is explained by the least squares regression using weight as the explanatory variable. Okay. This means that this model that we had, this linear model that we had found with our regression model, regression line, is a very good model to predict and estimate what the gas mileage usage is going to be for different weighted cars.